This is the third video on vectors. And now, if we're given a vector, in a minute we'll do this example. Say I have the vector W, and I'm told the magnitude of the vector W is 10, and the angle is 55 degrees. I'm asked to convert that into the IJ form of the vector. We'll call A the x part of the vector and B the y part of the vector. So here I'm given a vector, magnitude, direction, and I'm asked to rewrite it in terms of I and j. It's not too hard to do. Let me just quickly show you. I could just give you the little sort of formulas, but it's pretty easy to show you how we get those. So let's just draw in here some random sort of vector. There's an angle. Just for fun, we'll call this vector W. So therefore the length of this, and once again we're going to think of this as a right triangle. Let me just call this vector, where the A is like the x part, the B is like the j part. So in a sense, this length is like the x, or I could say the A, if I write it in ij. And hopefully you see that the top of the vector, this is like the y, or the b part, or the j part of the vector. Now here's some very straightforward applications of some trig functions. If I'm trying to find this distance x here, let's assume I know my magnitude, so I know the hypotenuse, and I know the angle. What can I use to figure out the length of the bottom of this triangle? Well, SOHCAHTOA cosine adjacent over hypotenuse adjacent is like x, hypotenuse is magnitude of y. So really, if I'm looking for the x part of this, it's just simply the magnitude of my vector times the cosine of the angle. Now I want to get this side over here. This is like the j part, or I'm going to call it y, or the b part of the vector. And if you think about it, the sine of theta, sine, so opposite over hypotenuse. Therefore this length y, which is that length right there, right? That's y. Over the hypotenuse, which is once again the magnitude of w. And now if we sort of solve this for y, we can say y, or the length of the j part of the vector, is the magnitude of the vector times the sine of theta. So I could rewrite it now. If I want to say, in this case, if I want to write it in ij, what you take is the magnitude of your vector times the cosine of theta to get the I part, plus the magnitude of your vector times the sine of theta to get the j part. Sometimes they like to call this AB. So it's actually very straightforward. So for the problem we were given, magnitude of 10, angle of 55 degrees. Magnitude of 10 times the cosine of 55 degrees. That's the I part, plus magnitude of 10 times the sine of 55 degrees. That's the j part. You simply grab your calculator. 55 degrees cosine times 10 equals 5.7 I plus 55 degrees, the sine of that, times 10 equals 8.2J. And just for fun, if we did a quick sketch of this to see if those numbers look reasonable, my direction, 55 degrees, is maybe right, halfway is 45. Maybe I'll go like this. So if that's 55 degrees, and maybe that's a length of 10, it's sort of saying that down here, I'm 5.7, over here, 8.2, looks reasonable. All right, not too hard. Now the good thing about doing this, you know, when we went from IJ to magnitude direction, especially when we did the angle part, we had to be careful because we had that inverse tangent. Well, the good thing is when we go from direction magnitude to IJ, we don't have to think quite as much. In other words, let me just give you an example. How about the magnitude of vector V is 5, and the angle, I'm going to make the angle 285 degrees. Let's just draw that real quick. Well, 270 is the negative y-axis. 285 is maybe over here somewhere. All right, so that's 285 degrees. Maybe a length of 5. The good thing is when you go create your IJ vector, you don't have to worry about your angle as much. In other words, you just plug in, you can just use the formula. So it's the magnitude of V times the cosine of 285 degrees, and that's the I part. I don't have to mess with this angle. I don't have to think of, well, do I need to use a reference angle? Nope. Just plug in the angle you're given, plug in the direction you're given, and the calculator is going to give you a correct answer. Then the J part, 5 times the sine of 285 degrees. So the nice thing is, no having to think about it and figure out what quadrant I'm in. Cosine of 285 times 5 equals 1.3 I, and then the sine of 285 times 5 equals Does this look reasonable? 1.3i, negative 4.8j. 1.3 here, negative 4.8 here. Yep, looks reasonable. So the nice thing is when you're going from direction and magnitude into ij, you can just follow the formula and you don't have to take any special precautions. Now, the thing we want to do now with vectors is do what I call math with vectors. In other words, there are times when you'll want to add two vectors together, or maybe subtract two vectors, those kinds of things. So let's see how it's done. Of course, the key is what form are the vectors in that you're given. If we're given vector v, let me go way back and use the original form of the vector is 2, 5, and vector w is 4, 2, what happens if we would add those vectors together? Well, it's very straightforward. When you add two vectors together, you simply add the x parts. 2 plus negative 4 is negative 2. 5 plus 2 is 7. We could subtract these two vectors. V minus w, the x part, 2 minus a minus 4, which is 2 plus 4, which is 6. And then 5 minus 2 would be 3. And let's do one last thing. Now we can use, we talked about this a while ago, these scalars, which is like multiplying by a number. 2v plus 4w. Really what it is, 2 times the vector v plus 4 times the vector w. If I multiply out these vectors, this first vector now becomes 4, 10, and the second vector becomes negative 16, 8. So now finally adding them together, 4 plus negative 16, negative 12, 10 plus 8. Hopefully I didn't make any math errors. Now the thing is, hopefully you see, if I had been given these vectors in ij, like if v had been 2i plus 5j, and if vector w had been negative 4i plus 2j, hopefully you see that all this same stuff is very straightforward. In other words, if we were to add the two vectors together, you simply add the I parts and then the j parts. Except I can't add. It should be negative 2. And you see negative 2i plus 7j is negative 2 plus 7. I'm not going to do the rest of these because hopefully you can see that it's very straightforward. So adding, subtracting, even multiplying by scalars, vectors, when they're in the ij or the pointy brackets, very straightforward. One thing I'm not going to show you is you can look in your book and they show you how graphically vectors can be added together on the graph paper, but I'm not going to take the time. It's not really a point of emphasis. Now here's an interesting question. How about if I'm given these same two, actually not the same two vectors, two different vectors? Because now I'm going to say the magnitude of vector v is 5. The angle of vector v is 40 degrees. Then I have my second vector w. Its magnitude is 6. And its angle is 100. Just for fun, what I want to do is have I want to take vector v, multiply it by the scalar 3, and add it to 2 times the vector w. And these are my original vectors. So how can I do this if my original vectors are in magnitude and direction? I don't know, can I multiply vector v by 3 times the magnitude, 3 times the angle? No, that actually would not work. What you have to do is you have to take, if you're given vectors with magnitude and direction and you're trying to do some math like this, what you have to do is you have to convert both of these vectors, write them in the ij form. When both these vectors are written in ij form, then you can go and do your math, add, multiply, whatever, and then after you combine them, you'll have your answer in ij form, but then you have to convert it back to magnitude and direction. In other words, the answer to this problem is going to be a vector, but they want it to be magnitude and direction. They don't want the answer in ij, they want the answer back like it started. So let's go and do this. It's not hard, it's just a little bit tedious. Let me rewrite the problem so it's clear what we're doing here. So here's the vector v, the magnitude I said is 5. The angle is 40 degrees. Here's our second vector w. Its magnitude is 6 with an angle of 100 degrees. And basically what I want to do is I want to take the vector v, multiply it by 3, and add it to the vector w multiplied by 2. So let's write vector v in ij form. We know how to do that, right? You take the magnitude times the cosine of the angle. That's the I part. So this is all for vector v. Then the magnitude times the sine of the angle. That's the j part. In a minute, we'll actually figure out what these numbers are. Do the same thing for the w vector. The magnitude times the cosine of the angle, and then the magnitude times the sine of the angle for the j part. So now you grab your calculator, make sure it's in degrees. So 40 degrees cosine times 5 equals 3.8. And then 40 degrees sine times 5 equals 3.2j. So that's vector v. Vector w is cosine of 100 times 6, negative 1.0 I. And then sine of 100 times 6, 5.9 j. And actually, this is another problem where I really encourage you to try and draw a sketch, because then when you're done, you can see whether your answer looks reasonable or not. Vector v, an angle of 40, length of 5. Let's just say that might look like this. Vector w, angle of 100, vector of 6. This is going to be a little bit longer. It's going to be pretty close to the y-axis. Now, if you think of adding these two vectors together, I didn't show this, but basically what you do is you take and put them tip to tail, and then you end up, this would be just adding them together. Of course, our problem is we're doing some multiplying too, so this is even not quite the same, but just to give you an idea. So as a matter of fact, I almost forgot this. What I really need is 3v. So really 3 times 3.8, 11.4i. Then 3 times the j part, I think I can do that in my head, 9.6j. And then 2 times the w vector, be negative 2i. And this should be 11.8j. And now I'm going to add them together. So the point is, now that you've rewritten these vectors in I and j, we can add them together. So therefore, 3v plus 2w is going to equal 9.4i plus 21.4j. There's your final vector, but of course it's in the ij form, and we want it to be in magnitude and direction. But we know how to do that. The magnitude of this vector, square root, you square the x part, you add it to the square of the y part and take the square root. So 9.4 squared plus 21.4 squared equals, you take the square root, 23.4. And then the angle, now if we think about this vector, maybe 9, maybe we'll call this 10, so 9, and then 10, 20. Look about like that, just see if that makes sense. So you take the y inverse tangent of the y part over the x part. So 21.4 divided by 9.4 equals inverse tangent 66.3 degrees. And that looks pretty reasonable. All right, so that's interesting. So that's how we add and subtract vectors.